All right, I left this off at the very end here, but let's just summarize things to remember. T is always your time. T is always your time. And really, it's playing the same role as x, right? We're used to writing x squared and plus something x, but it's the same idea. We're just using t because it's time. Now, h or d, we kind of use one or the other. H is going to represent the height of whatever projectile we're talking about, whether it's you jumping off the diving board, whether it's a rocket. It's playing the role of y. It represents the y value of our quadratic equations. So the last thing to remember is that when we're going to hear this question a lot today, when does something hit the ground? When something hits the ground or water, might be jumping off of a cliff into some water, you have to remember that your height equals 0. That's vital, absolutely vital to remember. So what I want to do is I want you to move to the next sheet of notes, and we're going to look today that finding first x-intercepts, meaning when we're finding x-intercepts, we're trying to actually find when something hits the ground, because remember, x-intercepts are the same as solutions or the same as zeros. So let's start with this basic one right here. We have Eli is throwing a ball off of a cliff into the ocean, right? And the question is, when will this ball, that when we throw it, how long did it take for the ball to hit the ground? And it's absolutely imperative that you ask yourself that question at the very end. You have to know, what is this question actually asking for? I'm going to go back up and highlight the equation, right? Here's our actual equation. And I don't have Desmos available to me for this question. This would be a non-calculator question. And at first, you're like, well, how in the world do we do this without a calculator, without a Desmos? But if you notice, every single one of those three terms can be divided by a number. So I'm just going to write them again. Negative 3t squared plus 3t plus 270. And so we have to set it equal to 0 because we're trying to find out when it hits the ground, just like we talked about here. That means that it equals 0, right? All right, so what we're going to do now is we're going to get rid of that GCF. We can divide every single one of these by negative 3. Now, why negative 3? Negative 3 because our line leader was negative. The first in line was negative. Okay, so we're going to divide by negative 3, and let's see what our new equation ends up being, right? If we divide by negative 3, we end up with t squared because negative 3 divided by negative 3 cancels to positive 1. When we divide positive 3 by negative 3, we get negative 1t. So I'm just going to write negative t. And then when you divide 270 by negative 3, just look at the 27. It goes in 9 times. And then you put a 0 on the end because we ignored that 0 for a second. And there we go. There's our new equation. And that equation can be factored a whole lot easier. All we do is do 1 times negative 90. That gives me negative 90. T-chart. I can already see the ones that are going to add up to negative 1. The only one that's going to add up to negative 1 will be negative 10 and positive 9. And notice we can cheat. We can skip because our a value is 1. Only because our a value is 1, we can jump straight to the binomials. So t minus 10 in parentheses and t plus 9. Remember, if you forgot, I'm allowed to skip because my a value is 1. If my a value wasn't 1, we would not be allowed to skip. Almost there, gotta solve. So we're gonna draw our big T here. If I solve this, I add 10 to both sides. So t equals positive 10. Subtract 9 from both sides on this side. T equals negative 9. Now remember, T stands for time. Is it possible to take negative 9 seconds? Doesn't even make sense, right? So we get rid of that negative answer like we've done many times before. And our answer is right here. How long is it going to take for the ball to hit the water? It's going to take 10 seconds. So you can see that this is what we're trying to do now. We're trying to use the skills of factoring and solving by factoring to actually answer projectile motion questions. That's what everything we've been teaching up until now has been for this very reason, okay? So I want you to try a couple of these more on your own. I'm not going to do all of them. So I want you to try the next one on your own, number 2, And at the beginning of the next video, I'm going to give you the answer to it to make sure that you were good to go.